allow time at the end of the webinar for Q&A, so please write your questions in the questions dialog box as they come to mind. If we don't have time to answer all of the questions today, we will get in touch with you personally after the webinar. Next slide, please. So for those of you who are not familiar with DCL, we provide data and content transformation services and solutions using the latest innovations in artificial intelligence, including machine learning and natural language processing. DCL helps businesses organize and structure data and content for modern technologies and platforms. You can see on this slide a list of some of the services we provide. Next slide, please. Today, Nave Greenberg will discuss automation in S1000D conversion projects. Nave is the Director of U.S. Defense Development for DCL and is an industry expert with S1000D conversion. He has a long history with structured content, XML, and other types of conversion projects. Next slide, please. But before I turn it over to Nave, I would like to take a quick poll to gauge where this audience is in terms of S1000D. So everyone should see a little poll on their screen. If you could just answer the following question: do you currently practice content reuse in your organization? And the options are: yes, I have a system in place that enables reuse. Yes, but I don't think our system is optimized. No, but I want to enable reuse. No, I don't think we need to reuse content. Which I'm not sure why you're on the webinar if that's your answer, but we do accept all answers. So I'll give just a couple moments to collect responses. Okay, I'm going to shut the poll now, and we'll look at the responses together. So 30% of you do have a system in place that allows for content reuse. 20% practice content reuse. However, there are doubts whether the system is truly optimized in a way that is useful. And 50% want to enable content reuse. So with that, I'm going to pass it over to Nave, who will be able to help you get started. Nave.
Okay, thank you, Marianne. Good afternoon to everyone. As Marianne just mentioned, we are going to discuss the concept of automation in S1000D, both in conversion and QA. This actually applies to the entire migration process from initial analysis of the legacy data to actual conversion and QA. So a lot of people shy away from S1000D, and to try to understand why, you can start with the challenges of any legacy conversion. With legacy conversion to any XML standard, you have the typical conversion issues that are challenging and that you need to deal with. I'm only going to cover a few of them, but it will still show the typical challenges of any legacy conversion. The first issue is, how do you guarantee that you're not losing text or even adding text during the migration? Tables can also be a challenge. I mean, tables may not sound like it's a big issue, but it is. You have the row spanning, the column spanning, cell merging, inline images, all are items that require attention to details. If you have a robust conversion process in place, you can handle tables successfully. If you're going to overlook the challenges with tables, you will spend a lot of time fixing them after the conversion. That's not so easy, or it's time-consuming task once it's in XML. Math and special characters can also cause a lot of headaches. S1000D specifically doesn't really handle MathML, so you need to take that into account. I think there's some talks about allowing MathML, but until it's fully implemented, you will probably need to treat them as images or maybe link to them as an external file. The issue of people and legacy can be really a webinar by itself. I'm quickly going to touch on few examples. The technical writers definitely fall under category of people issues. Writer creativity will lead to some very, very interesting solution to try and fit text on a page. It looks good in the legacy data, but trying to fit it into S1000D structure, or really any XML structure, is going to be a challenge. Simply because legacy data was not written with XML in mind. Even with more recent formats like HTML and XML, there are still ways to fool the DTD rules and insert a lot of inconsistencies. It's especially a challenge when you go to S1000D, because S1000D is really a conceptual departure of linear information, really turning the traditional book of chapters and sections into a collection of data modules. And to some people, it's difficult to adjust to. In S1000D, you're dealing with data module codes, illustration number controls, applicability, business rules, and other like S1000D specific rules, and that makes the conversion even more challenging. S1000D is also a pretty big standard, and even though you don't need all the bells and whistles that it offers, you still need to understand the main concept of S1000D to make logical decisions. And I already mentioned it, that legacy data was not written definitely with S1000D in mind, so trying to map data to S1000D is like trying to fit a round peg into a square hole. So this leads really to the question, is fully automated solution even possible? I guess the answer will vary according to who you're asking. Some people claim that fully automated solution is possible, while others say it's impossible. And the right answer depends a lot on many factors. In order to determine what's the right answer, you also need to ask the question, how do you define the matrix of whether a conversion is successful or not? Does it mean that if files were validated, they're considered good quality? If you take legacy data and try to fit it into S1000D using the so-called fully automated process, you may get files that are validated against the schema, but you'll probably lose most of the benefits of S1000D. But to the people that say that the automation is not possible and we maybe might as well manually tag the legacy data, I also say it's not really correct. I personally believe 100% fully automated solution is not really feasible, but I definitely know that incorporating automation, not only is it possible, it's really the right way to go in order to achieve more accurate and consistent output. So what is truly the correct approach? It's not always a clear and defined answer. Every really case will need to be analyzed, and you will need to find the right balance between automation and manual work. When making that decision, you really need to take into account how much time and cost would it take to develop the automation versus how much time and cost it will take to manually tag the data. It also depends on how much data you have and how complex the data is. But more importantly, take into account quality and consistency. Another factor to take into account is what type of resources do you have. Also look into how easily you can translate the conversion rules into automation and conversion process. So there are a lot other factors that that I can discuss, but I will move on and I'll cover some of them later on. Actually, before I move forward, just something quickly about QA, quality assurance, and QC, quality control. In conversion to XML, I always see QA as the master plan. That is really the main task, is to make sure that the process of conversion is developed and run correctly. QC I see as being the matrix of quality. So basically checking the converted files and finding real issues and fixing them. So if you detect any kind of issues, you can always go back and revise the so-called master plan or the QA plan and improve the conversion process. So again, in the spirit of S1000D and reusability, this is a slide that I almost always use. And the quote, if I had 8 hours to chop down a tree, I'll spend 6 sharpening my axe, should definitely be applied when you're dealing with legacy conversion and any kind of legacy conversion. The more planning and analysis you do up front, the less issues and problems you will have later on. Fixing your data after conversion will cost a lot, and it would lead to very inconsistent data. So how do you go about doing a proper analysis? First, you can start with asking some initial questions. For example, who are the stakeholders? And anyone who's involved in the project is a stakeholder. It could be the management, it could be the graphic team, your XML experts, the technical writers, but one major critical stakeholder that people tend to remember only later in the process is the final client or the final user. So for example, a soldier in the field or a technician that works on maintaining the system that the data applies to, you may be talking to the managers or the procurement department or whoever, but they're not necessarily the one that will be using the data. The final user must be involved in the process. You also have to take into account the fact that you need to set expectation up front and make sure that the client knows exactly what they're getting. You definitely don't want to deliver the product and only then, at the end of the process, find out that the client is not happy or they think they got something that they didn't really ask for. So always find out who is truly the final user, and that will make your life a lot easier. Knowing the budget obviously affects the way you build your process. I mean, depending on your budget, you may rely more on automation. You pick and choose what functionalities you have. If you have a lot of budget, you can, go for vector images versus raster images. Knowing, let's say, the critical milestone, such as revision cycles, company shutdowns, milestone in other ongoing projects, knowing all of these milestones will make you plan accordingly and develop a reasonable schedule. If you're dealing with a huge volume of data, you will need to take into account longer analysis phase, allocate time for review of the deliveries, allow you time to enhance or modify the process, or use automation, and many other things that you can take, sort of will vary according to your budget. It's also important to know what content management system or rendering tools will be used. In theory, if you tag to S1000D, you should get the same output regardless of the tool that is being used. But we all know that that's not always the case. Some attributes and elements that are used in one tool may not be needed or may need to be used a little bit differently in other systems. And try to get your hand on as much legacy data as possible. You can start analyzing. You can look for any consistencies, detect many structures that could be challenging to migrate to S1000D. The more you have, the more accurate your analysis will be. You will also need access to the business rules and the schemas. And all of that are really critical for the analysis phase. So really the right people is really when you start building your team, someone in your team should be comfortable with S1000D. You don't need to be a subject matter expert, and you don't need to know the entire standard of S1000D, but you definitely need to know the basics to make logical decisions during analysis and during the project-specific business rule development. So after you cover the initial requirements, you can move on and start working on the QA plan. And I mean, I covered that in the previous slide, sort of the difference between QA and QC. Agreeing on the rules, on the business rules, sounds simple, but it's not. It involves all the stakeholders. And it's not just agreeing, it's also understanding the rules. My advice is document as much as possible. When you're done documenting, walk through the document specification to make sure that everybody understands and that everything is on the same page. And by really specification, I mean the project specification or project business rules. And always have a sign-off process. It is very useful to create a sample file and output that goes together with the documented business rules to give the non-technical stakeholders, or really any stakeholders, a better understanding, a better way to understand how the final data would look like. And again, to some extent, it's really the first stage of a first step of a pilot. The pilot, and especially later, the limited production run, are ways to make sure the migration process is going according to plan. If things don't run smoothly, it always allows you to enhance the process and make it more robust. So this slide shows exactly what I was talking about, especially phases 1 and 2. During the analysis, phase 1, you should create the conversion specification after you analyze enough data and develop a project-specific business rule and a hand tag sample. You should definitely walk through the conversion specification with the sample data with all the stakeholders to make sure everybody understands the rule and sees what the data will look like. And to people that don't know S1000D perfectly, you can show them where sort of data will migrate. Okay, this used to be a section, now it's this data module, or so on. Based on the conversion specification, you can sort of picture the final product, and the hand tag sample that you're creating should match the conversion specification. Just phase 4, phase 5 is already the production phase, and really a good practice is always to revisit the production process and sort of sample production samples in case you need any kind of enhancement or improvements on the process. So the step in this workflow really applies to legacy data that is already in electronic format, maybe HTML, XML, FrameMaker, Word files that are perfectly styled, that was either user styled consistently, and you can use that for your benefit. But if legacy data is paper or PDF image, you need to have 2 additional steps before step 3. And that's text extraction that will include zoning, OCR, proofreading to make sure the text extracted properly, and file preparation that will include styling and prepping the files for conversion. And it's important to note that step 4 is not the only step where automation can be used. And I'll cover it later in the later slides. And again, I'm not saying that it's a fully automated process. What I'm saying is that automation can be used in every step, accomplishing some of the tasks that are associated with each step. So automation can start as early as inventory. You don't need something sophisticated, but something that will allow you to track the legacy unit throughout the process. Legacy unit can be a technical manual, a book, or maybe a chapter. I really suggest to keep it at a hierarchy level of a technical manual, simply because you don't know yet how it will be broken down to data modules. Because once the data is converted, you can have a common source database that will really handle the files and track them, but it's really just to track the legacy data throughout the workflow. And you can record some metadata on each of the units that can help you create useful reports. And metadata can be a batch number, number of pages, date the unit was received. And as you convert the units, you can track other metadata such as date that each of the steps was created in the production process. And this information can be useful to project delivery schedule to see if you're on time, confirm that the processes are working properly, and track each unit in what step of the production process that unit is in. And this is just sort of a snapshot of a process that we can see that you can tie any kind of search on the unit. So which units done through a DMRL, which units are done through conversion, which one is in validated against schema, which one is in QC. So all of that can be tracked and implemented using some sort of a production control system. So when you're dealing with legacy data, sorry, and many people don't do that, always think of how can I make the legacy data more S1000D friendly. It's pretty safe assumption that the legacy data will require some preparation before jumping into conversion. You have data that, again, in most cases was not developed with a strict set of rules that can be effectively enforced. So the goal is to try to normalize the data. You can do some preliminary checks regarding the legacy format. So if your legacy format is HTML, SGML, or XML, or any kind of tag data, you have a good starting point so you can check tag invalidity, cross-references, graphic entities, table structure, tag incompleteness, and other items. But if your legacy data is some type of a word processing format like Word or FrameMaker, it's not tagged, but you can check for the data flow. You can still look at table structures. If tables are just visually look like a table, you can change that and make them a true physical table. And what I mean is that in many cases, you have tab data or text separated by multiple spaces. So it looks like a table, but in reality, it's not. Another thing is that in word processing formats, you can use the paragraph styles if they were consistently implemented. You will also need to analyze the uses of text boxes, which appear sometimes on in FrameMaker and in Word, that if you convert them, they may lose during the migration, so you need a process for that. Any kind of text layer on images, hard or soft returns, all of that can be done by automation. Another format of legacy data is paper or PDF image. So many people stay away from paper because they think it's not possible to migrate to S1000D, or maybe that it's just way too expensive. Now, it's true that you need to deal with the quality of the pages and deal with scanning and OCR and zoning and normalizing the data after, but it gives you more option to prepare and manipulate the data and sort of massage it before conversion to make the conversion more successful. And you can also have the subject matter expert work in Microsoft Word or FrameMaker instead of XML and prepare the data, which there are a lot more people that are proficient in Word than XML. You can also have cheaper labor clean up the Word document. So it's not an impossible task. as many people think it is. And actually, one item that is not mentioned on the slide, it's the whole concept of auto-generated text. So depending on your source of the legacy data, you will need to handle it differently. So if your legacy data is already tagged like HTML and XML, maybe some of the legacy elements that will trigger an auto-generated text, you will need later on, like tools, special conditions, and other preliminary information. If your legacy is not tagged, some of the text appearing in the legacy data will not be required, as they will indicate some sort of content tagging. For example, the title procedure before a set of steps could be replaced by main procedure. This is just some items that you need to analyze before you get into conversion, regardless of the legacy format. Now diving straight into the steps of conversion and what automation can be used on them now. In many cases, when you OCR a page with math, special characters, or complex tables or images with text in them, you basically get garbage in this case, and it takes a long time to clean it up. One solution is to remove the graphic artifact or those problematic section and only deal with the narrative text. So on your left, you have the legacy file with two artifacts that if you OCR will basically give you non-usable text. This is the first artifact, and this is the second one. It doesn't have to be an equation. It could be an image or whatever. But if you pull it out, you see in the example to the right, if you have a method to pull those artifacts out, you're really left with pure narrative text that if you OCR will give you a very high accuracy of the data. So, and again, most OCR tools that are out there usually keep page coordinates and XY location of the OCR text. What we did, we took it a step further and allow us to link back to the artifact that were removed. So what you see here on the top part of the slide is an XML representation of an OCR page. So the XML representation is a capability that you can have in most of the OCR tools. Linking to the artifact that were taken out before the OCR and now are tagged over here in the image file name element is the additional capability. And the artifact that we pulled out are now in sort of an SVG format. Again, we can, the process of graphic migration is a totally different subject, but you can save them as any kind of image format. But you can link them back because you know the geography of the page and you know the coordinates, and you can link it back to the image. So now you have the legacy data in an ASCII format, and you can bring that ASCII format into a Microsoft Word and normalize it. And what I mean, apply unique styles to make your data a lot more consistent and making the conversion produce better results. Next, I want to talk about automation during the analysis phase. What we are doing when analyzing the legacy data is run a program that collects all the paragraphs in the legacy data and looks for any duplication and close matches. The result is a report that can help you with finding typos, normalizing your data, give clues as to where the data module and maybe applicability can be used. In most manuals, again, you can assume that the front matter or introductory section are similar across the data set, but exactly how much, like how many duplication and where else in the documentation there are redundancy, it's almost impossible to detect without some automation. So the first example on top, I mean, you can see the text in bold is the base paragraph that was extracted from the data, and the paragraph below it is all the variation that exists in the data that was analyzed. So in this case, you have very similar paragraphs, but the only difference is that sometimes the comma was used and sometimes it was not. So an exact match appears in 3 documents, and the variant appears in 2 others. So again, it could be a typo, it could be something that you can normalize and clean it. Now, if you clean it and insert a comma in those 2 cases, you have 5 locations that are exactly the same. And you can pull that paragraph again, either as an XML entity or whatever, and pull it out and use it once in 5 different locations. You can take it even a step further and say, once you find a paragraph that is a close match or an exact match, you can look before and above it and stack identical paragraphs. And again, that does not replace the analysis of breaking down to a data module, but it gives you a clue as to, okay, I have few paragraphs over here that are close match or identical. Maybe I can create a data module over there and reuse it. So by having a content reuse analysis, you have a preliminary method to detect applicability and inconsistency. So on the top over here, the first paragraph discusses FD-5200, and the second paragraph covers FH-5200. In this case, you can still use the paragraph, but maybe use applicability to distinguish between the 2 models. Another difference is that in the first paragraph, it tells you to visually inspect in accordance to this standard. And for this model of FH-5200, it doesn't tell you to visually inspect it. So again, it could be a typo, and even if it's not, you can still reuse that paragraph either by adding the word visually or by using applicability. And you can see by the tagging over here that sort of quickly created, I used applicability to distinguish between the 2 models. And again, this is just an example to show that applicability can be used. It's not necessarily the way you're going to tag it in your data. So as you can see, the benefits for reuse are increased consistency and reduced development time because you're dealing with less data, lower maintenance costs, again, because you have more consistent data and less data to deal with. It allows configuration to multiple publication, and by knowing your reuse potential, you can divide and conquer. Because one thing you can do is go through the content reuse report, find a set of documents that are in good shape and make that your base documents. Take other documents against those sort of base set documents and go back and adjust the document. So by the time you're ready for full conversion, you have like a set of sections that are identical and can be pulled out. So once you extract your data, whether the legacy data was paper or already in a word processing format, you can normalize it and prepare it for automated conversion. And the main purpose for normalizing the data is that first, it produces more consistent and accurate result. It allows software to deal with what it's really meant to, and that's running data through predefined rules, and also have a cheaper labor that can normalize the data. So you don't need a subject matter expert sort of looking at basic data over here. So you can create a QC software, and in this case, maybe a Visual Basic thing that will check the consistency of the styles that we use. And if you find any inconsistency, you can report them. So specifically in this case, you don't need to be a subject matter expert to understand that something went wrong over here. When you have a set of steps that was styled in whatever unique style that we use to indicate a step, you jump from number 2 to number 4. And we all know in some legacy data, it is possible that the numbering got screwy, but in many cases, it could be an indication that during the text extraction, one of the steps will merge with the other one. So in this case, you can see step 3 was merged with step 2. And there's other checks that you can do. You can do a counter and see if whatever you styled as a title, which I'm going to discuss later, that will be pulled to a DMRL, if there's some sort of sequence numbering that is associated with it. So if, let's say, you styled something as a hierarchy 1, and it's number dash number, and then somewhere down the line, you style the same title, but this time it's 2-23.1. If you style it the same way, something is flagged, and you can go back and see whether it was styled properly or not. And the reason why I showed this example is that a lot of time, if you look at the data, you will say, well, this is a step. You have A, B, C, D is going to be a step, but in another location, it's going to be a step in a number. So you can style it any way you want. You don't need to sort of be an expert to style it consistently, but by having a tool, an automated tool over here that otherwise it will be very difficult to find those inconsistency, you can make your data very, very consistent. And you can do a lot of checks. You can find typos and all that kind of stuff. Hard returns, if a paragraph begins with a lowercase, it can always be an indication for something suspicious. So again, one of the biggest goals when preparing the data is to make sure that you extract the title into a spreadsheet that in S1000D will act as a preliminary DMRL. And that concept of pulling the title to a spreadsheet can and really should be used in any kind of migration to XML, regardless of the standard. And the reason is that it gives you a great picture of how the data will be mapped before you even get into the conversion. And you can sort of change the mapping according to whatever let's say the subject matter expert tells you. In these 5 examples, the goal is the same, but the process may be different. So in FrameMaker, you may use the styles that we use, or you may use keywords or formatting. So chapter 1, chapter 1 is probably auto-generated text, but you need to find the best way to extract the titles to a spreadsheet, because you can't necessarily use the table of content because for 2 reasons. Number one, maybe when it was updated, it wasn't updated properly, and it's not linking to all the title. It may cover only the second hierarchy level and not sort of miss the lower hierarchy levels. So you really need to find a way to pull all the titles in, and that definitely has to be done by automation. Even when you have tag data, you have elements that will flag the elements to be pulled into a spreadsheet. Sometimes it's easy when you have a title, sometimes it's not, and it could be a procedure element without a title that later on will be mapped to a procedural data module. You may need to pull that. So you don't have a title, but you have an element that in the DMRL you can flag it as a procedural data module. InDesign is the same concept, it's the style, the structure. Microsoft Word is obviously for files. And PDF is, once you extract the data, you can style it properly. And really this slide shows how, regardless of the legacy format, the goal is basically the same. And you need to find a way to normalize each format. So whether it's your standard legacy of chapter, section, and so on, ATA, PDF, even early version of S1000D, the concept is the same, that all the titles are pulled inside a DMRL and are being mapped. And again, the DMRL is not just a way to map the titles. In the DMRL, you can also assign important information. For example, information in the identification and status section, or the value for tech name if you want to change it, let's say. You can also add any kind of special information. For example, state that an alert should be repeated in a specific data module, or insert all kind of preliminary data like tools or skill level or references before every procedure. And that could be data that is actually missing from the legacy that you can pull over here. And as long as it's consistent, automation can easily insert them back into an XML file. And the nice thing about that is that if you give that to a subject matter expert, they're not dealing with XML, they're not dealing with S1000D, they're purely dealing with, okay.
So as long as there is a defined rule as to how to add the metadata and the unique request, you can translate that to an automated process. So this slide shows you a concept of automated conversion software. And regardless of the legacy you're dealing with and the target XML schema you're going to, some items are handled the same. So as long as you normalize the data, you can program for these items and use it regardless of the legacy format. It allows you multiple source types to be taken in and pre-processed according to the source type. This is called the hub and spoke approach and is specialized to handle front matter, special characters, and a variety of tables, equations, and other structures that are known to be challenges during the conversion. So if a new requirement is needed, you only customize the individual module instead of building the entire conversion filter. So this approach saves you a lot of time and money because you don't have to reinvent the wheel with every new project. So items like cross-references, regardless of the legacy data, will look for keyword, figure, tables, refer to, and all that kind of keywords that appear regardless of the format. So as long as you normalize the source data, you can use that routine on any kind of input that you put in, and the result will be the same. But it does require you to analyze the data and see how you get to the approach where you normalize all your data. This slide is basically showing you an example of a typical QC of tag data. You can check things like table width, spaces before or after elements, suspicious short or long paragraphs or titles, possible candidates for missing or incorrect cross-references. Let's say if you have a figure below and there's nothing there, or figure 3 in manual, so and so, you need to look for those suspicious cases. You can look for image entities that are missing or do not follow a unique pattern, elements without any content in them. I can list a lot more, but all of these checks are almost impossible to do manually. So every time you do a review and you find an issue or something that you didn't pick up before, you can add to that QC check and run it as many times as you want. So it's something that it is a push of a button, but you need to analyze the result. This slide is more specific to S1000D. Again, you should actually must use tools out there like the breaks to check your data, but sometimes you need to think outside the box. Checks that are not thought of because legacy data is so unique. So every project you will require to find those project-specific checks, which is not the same as project-specific business rules, but are checks that you do because of the legacy data. So if I had to summarize an approach to take before dealing with the conversion and creating the automated rule, I will say know your legacy data and structure. And during the analysis and planning phase is when you learn the most about the legacy data and how it can be migrated to S1000D or any XML standard. Sometimes it's not possible to find all the inconsistencies during the analysis, but as the project progresses and you find these issues, you go back and update the process and the automated QA checks so you're not starting from scratch.
We have some questions. If we could dive into some of these, I think that would be great. One comment I do want to say to everyone attending, yes, the slides and the webinar will be available on DCLab.com, and you will get a link to that in a follow-up email. But let's touch on some of these questions, Nave. Do you have any examples where the return on investment on a project which has used auto conversion of data to S1000D has been demonstrated?
Okay, I mean, again, we are coming in, well, specific numbers, like monetary, it's kind of difficult to give for a company, but just a simple example, if you take into account how long it takes you to QA a page, and if you have to go paragraph by paragraph and review it, or hand tag it, it can easily take 10 to 15 minutes a page. Just think about manually tagging and so on. We estimated that process of extracting data, proofreading, and preparing the data is cut by a minimum by half. I mean, it's sometimes a lot more. And the reason for that, if you extract the data, just as an example, you don't need to go character by character. All you do, especially with simple diff, but if you check the first and second word and it's the same, and then compare that chunk of data to your legacy data, and there are no differences, you don't need to go character by character. Another example is all the cross references. Can you imagine going and clicking on 1,000 links and doing it manually versus if you have an address and if you have a target and a source, it's done by automation. So at least it will flag you the cases that are suspicious. You will need to do manual intervention, but we got to project where we easily cut down the processing, the conversion processing time by at least half. And that's why we rely a lot on automation. Besides being more consistent and more accurate, it does save a lot of time.
All right.
And actually, a great example, you know, we had a situation where somebody came back and said, well, it's really only 2 minutes a page to go and fix it in XML. But if you have 1,000 pages, that's 2,000 minutes. That adds up to a lot. If you can write a quick script, a QA script that takes you even an hour or two, the results are going to be a lot better. But you don't need to pay somebody to go and manually look at it, and we'll definitely miss it. But conversion-wise, at least 50%.
All right. Some legacy data is missing text that's required by S1000D. How do you go about it, and when do you decide it's just not worth converting? Can you speak to
that? Yes. I mean, it's always, you know, a lot of people say it cannot be done or it can definitely be done. And those extremes, you know, it really depends on the legacy data. Some descriptive data, you can migrate to S1000D with no problem. I mean, if it becomes a descriptive data module, it shouldn't be a major challenge. Procedural data module may be missing preliminary information, but the procedural steps are there. So you have few like really few methods you can approach it. If your legacy is paper or any kind of board or FrameMaker, you can really sit somebody and add that preliminary information before before the procedure or before the set of steps, or maybe break multi-step procedure into numerous procedures, and you can add or remove alerts in proper location and so on. Do the preliminary work in a word processing format, and the benefits on that is that a lot of people know Microsoft Word and they don't know XML, and you can also QA that data better because you can do a difference and see what was done and set strict rules to do that. Another thing that let's say if your data is not is already tagged, or let's say you brought it to a point that it's tagged. I think I covered it on slide. I mean, hopefully it's not a slide that you guys didn't hear me. Like for example over here. So all the missing data that is here is not in the legacy data, but somebody can sit down, a subject matter expert, and insert those legacy data or remove maybe introductory data. Sometimes introductory data is not needed, and again, it's to any kind of conversion. Like for example, the following procedures discussed, whatever. So you can easily add this data in your DMRL as another column and have conversion software insert it into your data module.
Okay, and one last question, and as a reminder, if we have not answered all your questions, we will be following up on an individual basis too. So final question, what if you don't have a CSDB? How does it affect the conversion process?
If you don't have a lot of technical writers or authors that will sustain the data, or any plans to produce any additional data modules, then it's not, in my opinion, it's not critical to use a common source database. And again, I don't know what's the magic number when it becomes too many technical writers, or how many, the amount of data modules that you need, but it will make your life a lot easier to manage them. You can do global updates, maybe revision control, any kind of searches on the data. And I personally think it doesn't stop you from conversion. Sustainment is a different issue, but as long as you tag to S1000D, let's say you're closer there. So it might be a situation where you tag the data and you bring in a common source database, or even an item after the fact, which is, again, it's not great practice, but you may need to go back and tweak the XML files. But that's why documentation is so critical. I mean, you can, if let's say an attribute needs to be changed or added or modified, you can do that by automation if your data is consistently tagged. So basically, it's not, in my opinion, it's not critical, but if you're doing a very large migration, I believe it's good practice to have it while you're doing the conversion.
All right. Well, thank you, Nave. Very informative. Thank everyone who attended the webinar. Thank you for hanging with us as we were challenged with a little bit of technical issues. You'll be able to access the recorded version of this webinar from the archive section of our website at dclab.com. We hope to see you in future webinars, and this concludes today's broadcast. Have a great day. Goodbye.